Okay, so in this part, we're going to talk about another graph and function attributes, and that has to do with continuity. Okay, so if you can draw a graph without lifting your pen, then the function is continuous on the interval. If a function is not continuous, it's said to be discontinuous. Okay? So there are three types of discontinuity that we see in figure 1. The first one is a jump discontinuity, right? That if I were to hop on this graph and kind of move along, in order to continue the graph, I need to jump down and continue moving on. That's why it's called a jump discontinuity, right? These are seen at x equals -2 and at x equals 4. We have a jump right over here, and we have a little jump right over there. We also have an infinite discontinuity seen here at x equals 0, because if I hop on the graph and I move, I'm going to keep on going up towards infinity. And then in order to continue on my graph, I have to move over. And if I were to try and go back, I'd be going all the way down to negative infinity. Okay? So we have that infinite discontinuity seen here at x equals 0. And that's because our function goes towards infinity. Right? Technically, on the left side of 0, it goes towards positive infinity, and on the right side of 0, it goes towards negative infinity. But at this moment, you just need to be able to identify that as an infinite discontinuity. Okay? And then we also have what's known as a removable discontinuity, right? We can see a removable discontinuity right over here at x equals 2, okay? That is a removable discontinuity because a point, if we put a point in and filled in that hole, we would remove the discontinuity, right? It's not possible to remove a discontinuity when it's a jump or it's infinite. Only when I have a hole, then we call it removable, okay? Now, once again, if I can draw my graph without lifting my pencil or without lifting my pen, we say that our function is continuous on that interval, okay? Now, a little bit more on continuity and how it affects domain and range. And these things are ones that you should be familiar with, okay? The possible inputs to a function is called the domain. In introductory courses, these will frequently be the x variables, right? So what values can I put into the function, right? What values of x is the function defined? That's the domain. The possible outputs to a function, that's called the range. In introductory courses, this will frequently be the y variable, okay? So what are my possible outputs? My possible outputs, those are my range. Okay, now, interestingly, if a function is defined for all real values of x, then the domain is said to be all real numbers. But it is possible to have a domain of all real numbers, but not be continuous. Look here on figure 3, right? I have my function defined for all values of x all the way up to this little open circle. My function's not defined there. But if I hop down here after that jump discontinuity, I actually am defined at x equals 1, and I continue to define going on. So this particular function, it has domain all real numbers. Interestingly, it also has range all real numbers. While even though I have a jump discontinuity right here, right, my function can go from here all the way down to infinity, and it can go from here all the way up to positive infinity. And this gap is actually covered by both the red and the blue parts of my graph. We happen to call this a piecewise function because it's made in pieces. Now, if a function is bounded, then the range is affected, right? If we have a bound to our function, the range is affected. But it is possible to have an unbounded function with the range that is limited. See figure 4. Right, so over here, look at my function. It's unbounded, right? Figure 3 is unbounded. Figure 4 is also unbounded because on this part of the graph, I can go to infinity. On this part of the graph, I can go into infinity, right? Over here, down towards negative infinity. We say that that's unbounded. But my range is limited, meaning that if I look at this, there's no values for the function over here between -1 and +1. right? So my range will be everything from +1 up to infinity, and everything from -1 down to -infinity. Okay, so interesting little pieces dealing there with domain and range, as well as continuity. What type of discontinuities would we have here in figure 4? Because infinity is involved, we call that an infinite discontinuity. And once again on figure 3, because we have a jump, we call that a jump discontinuity. Okay? Keep on with your work. As always, if you have questions, please do ask.